So now that we know how to find molarity and volume for acid-base reactions using our new solution-dilution equation, let's apply this new equation to a different set of reactions, mainly precipitation reactions. Here's an example. A 25 milliliter solution of 0.775 molar aqueous barium chloride required 37.2 milliliters of an aqueous ammonium phosphate to precipitate all barium ions to barium phosphate. What is the molarity of the ammonium phosphate solution? If we were using M1V1 equals M2V2, the first thing that we have to do is to find the balanced chemical equation. So let's start that. So as one can see, this is not a 1-to-1 mole ratio. Therefore, we can't just jump straight into M1V1 equals M2V2. What we'd have to do is to perform a whole bunch of stoichiometry to find moles, and then convert moles to moles, then divide the new moles by a volume to find the new molarity. That is a lot of work. With this new equation that I'm about to show you, it will make quick work of these types of problems. So let's begin with that. The new equation, as you can recall from the previous video, is N1 M1 V1 equals N2 M2 V2. So this formula is generally the same, but the only thing that's different is how you solve for N. In acid-base, you'd have to look at the charges of H and OH multiplied by their subscripts. For this, you have to look at charges and subscripts of elements. Now, what do I mean by that? Well, the first thing you have to do is you have to identify the solid. So the solid in this case would be here. Now you take a look at this. Once you take a look at this, you have to find the elements that comprise this solid. So the elements are barium and phosphate. So then you take a look over here and you see where barium is and where phosphate is. Phosphate is here, and barium is here. So now that we have this, let's take a look at the charges. Let's take a look at the charge for barium, and let's take a look at the charge for phosphate. Barium has a charge of 2+. Phosphates, on the other hand, have a charge of 3-. So the equation is still the same to find for N. You take N is equal to the absolute value of charge times subscript. Okay? So let's find N1 and let's find N2. Now, how do you know which N's to assign to? Well, N1 would correspond to the one on the left, so barium chloride, and N2 would correspond to ammonium phosphate, which is over here. So let's start with that. So let's see, for barium, which is N1, you would have 2, which is the charge, multiplied by its subscript, which is 1. So N1 is equal to 2. Phosphate, N2, is -3 times 1. Take the absolute value, N2 is equal to 3. So these are our N values, and these are what we want. So now we can plug this into our new solution-dilution equation to find our new molarity. Let's start with that. Okay, what I want to do now is to keep these numbers here and perform the equation. So N1 is equal to 2. Multiplied by the molarity, which is 0.775. You can multiply this by 25 milliliters, and that's equal to 3 times M2, which is unknown, multiplied by 37.2 milliliters. Okay? So now, basically, to find M2, it's just simple algebra. So what we want to do here is take M2 equals 2 times 0.775 times 25 divided by 3 times 37.2. And this gives us 0.347 molar. As you can see, it is much easier and much quicker to do it this way rather than doing multiple stoichiometry problems to get to a new molarity. Hopefully you can use this to cut down time on your exams and homework. Thank you.